So part 2 is vectors in the coordinate plane. What we did yesterday largely manually, in other words, with Euclidean tools and tactile applications and geometry, we're now going to do purely algebraically. And if you're like me, you're going to be like, whew, this makes a lot more sense. I've got too many lines on it. Can't see the word. Okay, so vectors in the coordinate plane. An algebraic treatment of vectors, if you will. So you performed operations using scale drawings. No, we didn't. I don't know what that's about. Represent and operate with vectors in the coordinate plane and write a vector as a linear combination of unit vectors. Those are our 2 learning goals for today. Some new terminology, component form. Now, I gave you a little preview of this yesterday because I knew you would need it for that gym kit activity, because it was really impractical to assess it the way, the geometric way. So anyway, the component form of a vector looks like this, where x is the displacement in the x direction and y is the displacement in the y direction. So unit vector and linear combination are based on 2 most important vectors. They are I and J, usually indicated with the capital letter, or sorry, the lowercase cursive letter, is what I meant to say, indicated with the lowercase cursive, I and J. I is 1 unit in the x direction, and J is 1 unit in the y direction. So a unit vector is either I or J, and a linear combination is when a vector is written in terms of I or J. So just for the sake of argument, let's say I've got vector U, and it is 3, -5. I could also write that as 3I minus 5J. So the left representation with the less than symbol, 3, -5, and then the greater than symbol is the component form. The right representation, 3I minus 5J, is the linear combination form. Stop if anything gets confused. All right, this is one of the key ideas for this lesson. So this next slide is very intuitive. It basically says to know the x and the y values for a vector, if you know the initial point and the terminal point, then the vector between A and B is going to be this right here. So the x sub 2 minus x sub 1, and then comma y sub 2 minus y sub 1. So you take the values from the terminal point and subtract away the values from the initial point, and that gives you the displacement in that direction of the vector in question. So if a vector started at 1, 1, and went to 5, 5, it would have 4 units of displacement, positive 4, in both the x and the y. Let's just use that as an example, shall we? What I find is the longer I write vectors, the more parentheses like my greater than and less than symbols become. So I apologize in advance if that happens. Okay, so that's how to find the component form of a vector given its initial and terminal point. All right, so what about initial point 1, -3, and terminal point B, be 1, 3. So let's just do a sketch here. So we've got 2 points. They are +1, -3, and then +1, +3. And the vector is going to be between those two. There we go. So that's vector AB, where this is A, this is B. Notice the half arrow hat there. So it's going to equal 1 minus 1 and 3 minus -3, which is 0, 6. Zero units of displacement in the X, 6 units of displacement in the Y. That's finding a component form for a vector given its initial and terminal form. Fundamental idea in vector analysis. Pretty simple, relatively speaking. Questions? Okay. Here's one for you. Tell me the vector. Express this in component form, given those 2 points. Stop me if you get confused and raise your hand. Okay. So tell me what this is. Hold 9, 6. Very good. So remember that it's important to label these properly, because if you switch the initial and terminal points, you'll get the additive inverses here. So just be careful about that. So this is the initial point, that's the terminal point. 5 minus a -4 is 9, 3 minus a -3 is 6. Okay, magnitude. So one of the other things we need to know about a vector is its magnitude, its displacement along this path. And that is given by something very similar to the distance formula. So if you're using the points, use this one. Formula, excuse me. If you already have it in component form, you can use this one. Now notice the absolute value symbols here. So this symbol gets a lot of work. First of all, in arithmetic, it's the absolute value. With matrices, it was the determinant. You remember that? And now with vectors, it's the magnitude. So this can mean 3 different things based on context. Here, of course, we're talking about vectors, and so this is the magnitude of that's what that means. And that can be quite confusing, just because we've used it in so many different ways so far. A lot of different mathematicians over the years have just decided to go to this old standby to represent this certain thing. All right, that's the finding the magnitude, so let's employ it. If I've got this same vector we had earlier, what is its magnitude? Well, we're given x1, y1, x2, y2. So the magnitude of AB is going to be the square root of y2 minus y1 squared plus. And you can put these in either order, it doesn't matter. I think you both put the x's first. Addition is commutative. In other words, you can switch the add-ins around and there's no difference in the result. Okay, so y sub 2 is 3 minus a negative 3, and then 1 minus 1. So that's 6 squared plus 0 squared. Square root of 36, 6. So the magnitude of AB is 6 in this case. All the displacement is along the y-axis, which makes sense. Any questions, thoughts, comments? Just feeling okay about vectors? Okay. So here's one for you. Tell me the magnitude in this situation. So you're taking the time to write it down. It's good. Mental calculations here won't serve you too well. Oh, I got it. Yeah, you're right. Their results. Strength is the meticulousness of your notation. Or along the way, some math teacher cultivated good habits with you. All right, so Rachel, tell me what this one is.
About 49.
Well, that's definitely related to the right answer, but you missed a step. So it's going to be the root. Don't forget the root.
So 7.
Correct. Minus the negative. Yeah, predicted the answer there mentally. So there we go. So radical 49 and then 7. So don't forget to take the square root. Questions about that? Cool. Vector operations, addition, subtraction, and scalar multiplication all work exactly the way you would expect them to. With addition and subtraction, you add or subtract corresponding components. So you add or subtract corresponding components, and then scalar multiplication, you just multiply each component by that scalar. Add or subtract corresponding components. Just a little preview. When we come back on Monday, we'll do the last section in chapter 8. Then we're going to have a chapter 8 quiz I'll open up. And then chapter 9, part 1 on Tuesday. Wednesday, probably have the quiz due from chapter 8. Thursday, 9, part 2. Friday, 9, part 3. Then the following week, 10 parts 1, 2, 3, and then the test on 8, 9, and 10. Then the week of Thanksgiving. Monday we'll do chapter 11, just one section. Tuesday we'll do chapter 12, just one section. Yes, that K is any scalar. So that could be, could look like this. And let's just say, so. That's what they mean with it. Okay, so let's do one. Now these are multi-step vector calculations. So when you have a scalar and addition, you're going to scale it first. So think of it kind of like PEMDAS. We'll do the scalar first. So this is 2 times so we're going to scale first. Then we're going to add or subtract the corresponding components. In this case, add. 4 plus 2 is 6. Negative 10 plus 0 is negative 10. So 2w plus y is 6 comma negative 10 for the x and y components respectively. Any questions about that? All right. So let's do 3y minus 2z. We've got a double scalar and a subtraction. Everybody with me so far? Just did the scalar. Now, 6 minus a negative 2 is positive 8. 0 minus a negative 8 is positive 8. These are gimmies on the test. You really ought to get these right. In fact, this quiz is a great opportunity for you to help your average. You guys did fabulous on the Chapter 7 test, by the way. Really amazing. Got a good, either I taught it extremely well, you learned it extremely well, or you guys beat the system. But in either case, I'm happy. If I teach you nothing else than how to use your resources, then I've done a positive thing. Okay, moving on. Here's one for you. Tell me what 3v plus 2w is. 3v plus 2w. Well, if you need help. Vectors used very frequently in game design. Yeah, three-dimensional physics is kind of the essential for building game engines. And you'd have to, like if you're designing a first-person shooter, you're going to have to apply 3 vectors to the bullet.
Probably the 3D vectors.
Yes, that's very good. 3D vectors are a big deal in Calc 3 if you ever take that class. And be well acquainted with some three-dimensional vectors. Okay, so let's see what we get here. Jesse, tell me what the x component is. Say again. The x component of the solution here.
6.
Okay. Can anybody testify that Jesse's correct? Good deal. And then Ian, what is the y component?
16.
Say again.
16.
16. Can anybody confirm Ian's result?
I got 7.
Okay, so maybe a boo-boo here. Let's take a look. So let's see. 3 times -1 is -3 plus plus 10 should be 7. A little sign error in there somewhere. Double check that for me. Okay, questions about this? All right. So finding a unit vector with the same direction as a given vector. This is a very important skill in using physics in real life. This is something that's done quite frequently with the vector analysis. This is the formula we will use. So if you have a vector v, this is the formula to get the unit vector u that is 1 unit in the direction of v. It has 1 unit of magnitude in the direction of the vector v. So we've got a vector v here, or -2, and we want to find its magnitude. So we're in component form, so we're just going to use that formula. And 2 on the square root of 5 is what I wind up with there. The magnitude of v, which I need to plug into that formula. So I got the magnitude of v, 2 on the square root of 5, and we'll plug it into that formula. So u equals 1 over 2 on the square root of 5 times 4 comma -2. And so that is 4 over 2 on the square root of 5 comma -2 over 2 on the square root of 5. And so that is 2 over the square root of 5, which we're going to rationalize. -1 over the square root of 5. Almost done. One more step. We need to rationalize those denominators. Multiply top and bottom by square root 5. Do it again. Okay. There we go. So this is U. The unit vector in the direction of V. A little more challenging. As always, stop me if you're confused by anything we've discussed. Okay. So here's one for you. I'll write the formula. And we want to do that for W. So just plug W in for V in that formula. Find the corresponding U. So you're giving me the unit vector in the direction of W. Going to have kind of a funky radical in this case. Getting rowdy next door. That's okay. My goodness, that was so much worse last year. Out of control last year. Make sure to rationalize denominators. That's right. Just end it right again. That one doesn't reduce. 17.2, which are the primes. So you're going to write it just like that. So that's the magnitude. You plug that into the formula, you see it. Excellent, sir. This let's just run for 5 squared should be plus. Which doesn't now. Just distribute and rationalize. We should be on the right path. Okay, so let's see how we did here. Rowdy, what's my X component?
It's 5 radical 34 over 34.
Excellent, sir. And then Bristol, what's the Y component?
I mean, negative 40 over 34 over 34.
Excellent. Very, very good job. And often we write it with U and then a subscript of the parent vector. So U sub W is the unit vector in the direction of W sometimes. You can also use that to mean the projection of one vector onto another. So this notation shares a few different vector things. Infer from context which it is. Okay, so a unit vector is a linear combination of unit vectors. So here's our task. We've got an initial point and a terminal point. We need to define it in component form and then convert that component form to linear combination form using I and j. So first of all, x1, y1, x2, y2. So DE equals 2 minus a negative 3, comma, 6 minus a negative 3. So I could rewrite this as 5i plus 9j. So the last step is the only new thing here. And that should be pretty intuitive to you. You're just replacing every unit of x displacement with I and every unit of y displacement with j. So it's a way to write it more algebraically, if you will, without that component vector. The vectors are now hidden, see? So, advantageous in some calculation. Question? All right, cool. I think we're good to go on this. So now we need some formulas that they didn't give us yet, which are, if I've got a vector with displacement A comma B, then I can rewrite that as the magnitude of V times the cosine of theta, where theta is its angle to the horizontal, comma, magnitude of V sine theta, where theta is the angle to the horizontal. So this formula we need before we proceed. Yeah, you guys are excited to see trig again, I can tell by your mumbled complaint. It does sneak its way in. Not in chapter 10, but in 8 and 9, especially 9. 9's cool though, especially if you're a graphical person, visual person. You'll dig chapter 9. It'll give you some tricks to do on the calculator that will impress people. Okay, so back to where we were. Yeah. So let's find the component form of the vector V as magnitude 7 and angle to the horizontal of 60 degrees. So that means it's going to be 7 times the cosine of 60 degrees and 7 times the sine of 60 degrees. So that's going to be, remember your unit circle. You guys kind of always sucked at the unit circle. It's been a great class, but you had that one glaring weakness when I asked you a unit circle question. You were baffled as though you'd never even glanced at it. So 7 times the cosine of 60 degrees. Jesse, what's the cosine of 60 degrees?
Is
Not quite. Let me refresh your memory. So remember my daughter Chelsea's little trick for this. You got 30, you got 45, and you got 60, okay? So 0, 30, 45, 60, 90. This is first quadrant. That's all you need, because the rest of it you can infer from symmetry. So this is 1, 0. This is 0, 1. Those are quadrantal, and as a consequence should be super easy. But for the rest of these, everything's a fraction over 2. And then you just go 1, 2, 3, 1, 2, 3. And you put a square root over everything that's not a 1. So this is what I'm looking for, Jesse. The x displacement of the 60-degree radial arc is the cosine of 60 degrees. 1/2. So 7 times 1/2. And then Riley, tell me what the sine of 60 degrees is.
Radical 3 over 2.
Good. And that's the speed at which you should give me the answer. And of course, it's trivial now that I've written it, but that should be that present in your brain. So we'll write this one more time in fully simplified form. Which is 7 over 2, and then 7 on the square root of 3 over 2. I'm convinced, Holden, that I had COVID in 2017, and I coughed for 6 months.
Dude, I'm serious. I think my mom and like her boyfriend had it because they swear they did too. They were like dying.
Coughed for 6 months. You know my level of fitness. Work out every day, run miles. I know you do the same. I had a persistent cough for 6 months.
COVID was a thing. I was getting this.
Yeah, bronchitis is a coronavirus. Coronaviruses have been around since, before humans. They mutate, of course. So the 2019 flavor is slightly different, but I think I had a pretty serious COVID style infection in 2017. Okay, so here's one for you. Find the component form of the vector v, where the magnitude of v is 12 and the theta to the horizontal is 300 degrees. No, it's not. See, if he doesn't have a fever, he's not.
Yeah, no, I'm not gonna. I did my quarantine.
The damage to the lungs remains after the virus has been purged.
I went back to wrestling
Is
yesterday.
that 3?
I bet, dude. It's, yeah. Tell me the. That's what your work should look like. What corresponds to 300. It's symmetric, but you're in Q4. So in Q4, you got positive x, so it's going to have the same x value, but the y value will be negative. So the same absolute value on the y. So change the sign.
Wait a minute. So they both did?
Say that again.
So they both did.
Just do that. Okay, so let's go over what you did. Tell me what to write right here, Ian.
Well, when
You're skipping a step, but you were correct.
Oh,
Cosine of 300 is what I'm looking for there. That's okay. You had it right. Bristol, tell me what to write right here.
well, sine.
Good. And then Ian let the cat out of the bag here. That's okay. And then Rowdy, what goes here?
12 times negative radical 3 over 2.
Excellent. And then when we reduce those, yeah, no. Get that. Okay, questions about that, anybody? Cool. Find the direction angle. So here we're going to have to use some inverse trig. So we got P with positive 2 units of displacement in the X and positive 9 units of displacement in the Y. We're going to need a little sketch of it, I think, to understand this. So that vector starts at the origin and goes to 2, 9, like this. And you think about, how would I find this theta? Well, I've got a triangle of sorts with 2 units here, 9 units here, and I want to know what that angle is. Do you see how inverse tangent is going to make that able to be found? So we'll use theta. I use theta over there. So use theta again. So tangent of theta is opposite over adjacent. And so theta is the tangent inverse. Make sure you're in degree mode, which I am. I'm already. Sure, but 77.5 to the nearest 10. So if you have component form, this is the mechanism by which you can find that theta. Be careful though, because remember that the tangent inverse can only give us answers from negative 60 or negative 90 rather to 90. So anything in Q2 and 3, you're going to have to infer from symmetry. You know, so if it gives you an answer in Q2, but you know it should actually be, I'm sorry, in Q1, and you know it should actually be in Q2, you're going to have to trace across the unit circle and find that corresponding angle, the one that is the same distance from 90 degrees.
What is the symbol that's after the 77.5?
Degrees.
Whatever. That's degrees. Okay.
Yeah, sorry, buddy.
I thought so. I just wasn't sure.
More clearly a degree there. Okay, so I think we're good to go on those. Find the direction angle to the nearest 10th. Yeah, we did that. Vector operations. Okay, so this is an important one. Because again, the real strength of vectors is their applications to real world situations. So soccer players running forward at 7 meters per second. So all the displacement is in the x-axis. And kicks a soccer ball with a velocity of 30 meters per second. So he's running, or she, and 7 meters per second is his body's momentum. 30 meters per second is his or her foot's momentum. And then we have 10 degrees to the horizontal for that soccer ball. So the net of forces applied on the soccer ball, the magnitude, is going to be 37. We'll just call this vector S for soccer ball. So it's going to have a magnitude of 37 meters per second, which is a pretty stout kick. I'm not sure it's entirely possible. That would be pretty unbelievably fast. And then our angle is 10 degrees. So they want to know the speed and direction. Well, that would be the way to describe it. I wonder if they're looking for anything else. I guess that's it. Kind of trivial. So that assumes the kick is perfectly horizontal and the runner's momentum is also perfectly horizontal, which would not actually be the case. You'd lose some energy. You couldn't kick it at a 10-degree angle if your foot was perfectly horizontal to do. So you would have some Y displacement here. Oh, actually, I see. We can't safely make that assumption, so hold on. So we could assume this. We can't assume this. So this is 30 meters per second total. So this vector actually is going to be, we'll call this one S sub 1 and this one S sub 2. So S sub 2 is going to be like this. And cosine of 10 degrees, that's not on the unit circle, of course. But that fella just in and out quite a bit, isn't he? We see him more than I see some of my students. About 29.5. And about 5.2. So if I add this 7 here, well, that would be can't assume the kick is perfectly horizontal if it's got that 10 degrees of lift. So that's why I had to revise my solution here. Okay. I think we're good to go on this. So if you guys would complete page 497, 2 through 18 evens only, and then also 19. In case you didn't know, Biden took the lead in Georgia last night.
I checked this morning, it was up by like 900 votes.
It's extremely narrow, within the margin of clerical error. So there will definitely be a recount if that holds. All right.